Let's take this circuit. In the previous video, I did one example using NMOS circuit. Then I ran out of time, so I'm going to attempt to do a few more examples today. So this is example 2, where you have a PMOS circuit, and given a few things about the circuit, as you can see in the picture there. And the question, can we find what I sub D and VDS? Well, I'm going to assume that my PMOS is in saturation. And if it's in saturation, two things I need to validate. This one is the current. First, I need to validate these two conditions, that VGS is less than V threshold, and VDS has to be less than or equal to VGS minus V threshold. If I can satisfy both of these conditions, then my assumption I'm in saturation is correct. Well, first thing first, can we find I sub D? Let's look at that. Take a sheet here, move this up. So I sub D is equal to what? It's this voltage. Notice this actually PMOS, so that's the drain, this is the source. And this is DS right there, VDS. So I sub D is equal to this voltage, which is VD, minus this voltage, that's 0, divided by 4K. That's 4 over 4K, which is 1 milliamp. Perfect. I need to know what my VGS is. Well, VGS, it's VG minus VS. The voltage at the gate minus the voltage at the source. Well, this is my gate. And if there is no current going through that, there is no drop here. So this voltage here is the same as this one. So it's VGG minus the voltage of the source, which is 5 volts. Well, bummer. I don't know what that value is. I need VGS. What else do we know? Well, we know that I sub D to be 1 milliamp. Wait, we have an equation here. There's I sub D. Let's put in 1 milliamp for it. Equals K, which is a quarter milli. Remember, this is in milli, the units for K. So the millis really will cancel each other out. Times what? VGS minus VT. Well, what's V threshold? That's a -2. And you're going to square it. So if you multiply both sides by 4, I'm going to have 4 equals VGS plus 2, and you square it. And if I use the square root method, that says VGS plus 2 has to equal plus or minus the square root of 4. And the square root of 4, we know that's a 2. And now to solve for VGS, we subtract 2 from both sides. So one solution for VGS is going to be -2 plus 2, which is 0. And the other solution has to be what for VGS? -2 minus 2, which is -4. Well, this solution does not make any sense. Why? Because you want VGS to be less than the threshold voltage, which is -2. Is 0 less than -2? No. Is -4 less than -2? So that should be my answer for VGS. By the way, if I know VGS, can I find VGG if I need it? Well, from this equation, -4 equals VGG minus 5. If you add 5 to both sides, you have 1 equals VGG. So if we need VGG, I'm in good shape. Remember, I only satisfied one condition, that VGS is less than V threshold. The second condition I have to satisfy is this one. Is VDS less than or equal to VGS minus V threshold? If the answer is yes, I'm done with the problem. I found everything about the problem. So let's check that. Is VDS less than or equal to VGS minus V threshold? Well, I know what VGS, I just calculated that. Where's my number? It's -4 minus, what is the threshold voltage? That's a -2. So what's that number? That's a -2. Is VDS less than -2? Well, we need to know what VDS is. Well, VDS is equal to VD minus VS. Let me go back to my circuit. This is the drain, and the voltage here is 4. This is the source, the voltage here is 5. And what's my VDS? -1. So now the question, is -1 less than or equal to -2? The answer is no. What does that mean? That means our assumption is inaccurate. We made the assumption we are in saturation, and the math tells me, no, we're not. So we are not in saturation. So let me write that down in big writing. Our assumption, I want you to know that, was incorrect. So what do we do now? Remember, the process of solving these, you make an assumption, you prove the condition for the assumption, and if the conditions are true, you get your answers. So I made the assumption we're in saturation, and the math tells me, no, you're not. We have two other modes. Either you're going to be in cutoff, which I doubt it. You got a voltage here, because if you're in cutoff, you don't have any current there. Or you could be in ohmic mode. So let's make the assumption let's assume here that the PMOS is in ohmic, or sometimes call that triode region. That's another way of saying ohmic mode. Linear. And if you're in the ohmic mode, let me see if I can find my equation. My current, notice, is different than the current here. In this one, this is really K here. VGS minus V Thevenin squared here. I sub ds. Instead of SD, I'm reversing them. But here, if you are actually in this mode, it's going to be K times. This equation will be 2 times. I don't like SG, so I'll use VGS. VGS, I use lowercase because my uppercase are horrible, minus V threshold times VDS minus VDS squared. So if I assume I'm in the ohmic mode, I got to use that equation now for my current, not this one. You can see why I always choose saturation, because this equation is much easier than that. So let's put that equation there. That's my notes from last, I don't know, 2 or 3 videos ago. So if I'm assuming I'm in the triode region, that means my current I sub D, let me write that equation down, K times 2 times VGS minus V threshold times VDS minus VDS squared. Now, did VDS really change? Still, this voltage minus that voltage. So VDS for this example didn't change, ohmic or saturation, still negative 1 volt. The threshold voltage what's the threshold voltage? Equals what? Negative 2. So let's plug them in and see what's going to happen. So I sub D, which is 1 milli, let me just move these papers aside. I got 10,000 pieces of paper in front of me. And put them here. I sub D, which is 1 milliamp, equals K, which is a quarter milli, times 2 times VGS minus a minus, that's plus 2, times VDS, which is negative 1, minus VDS, which is negative 1 squared. The millis cancels the milli. Multiply everything by 4. 4 equals 2 times. Let's do the math and see what will happen here. Or you know what? What's minus 1 times 2? This will make that a minus 2. Let's do it this way. VGS plus 2 minus a 1. So when you bring the minus 1 to this side, that's 5 equals negative 2 times VGS plus 2. Divide by negative 2, negative 2.5 equals VGS plus 2. Subtract 2 from both sides, that tells me VGS equals negative 4.5. One solution to VGS. Now let's see if our assumption is correct. We made the assumption we're in the ohmic mode. So is VDS, DS is negative 1. So let's check this, verify. We know VGS negative, so let's check. Now, if you are in the ohmic mode, the two assumptions we made, what is my sheet here from before? If you are in the ohmic mode, you need VGS. Let's look at that. This is a lengthy problem so far. We need to prove that VGS is right there less than V threshold. And I also need to prove that VDS is larger than VGS minus V threshold. So is negative 4.5 less than negative 2? Yes, so we satisfied that. VDS, which is negative 1, is that greater than VGS, which is negative 4.5, minus a negative 2 plus 2? Yes, we satisfied both conditions. That means my assumption to be an ohmic is correct assumption. So my assumption was correct. And here are my answers. My assumption was correct. So we know what the current now is. We know the current for this one is 1 milli. Where is it? 1 milliamp. Somewhere I have found it. I know VDS. We calculate VDS somewhere. Where's my VDS? Negative 1 volt. I can also tell you what VGG from this equation. Going back to this equation, VGS equals VGG minus 5. So if I do that here, I'll just take a different color paper, pen. VGS equal VGG minus, what do we have? Minus 5. So I know what VGS, negative 4.5, equals VGG minus the 5, and we have VGG to be positive 0.5 volts. So we knew everything now about that is PMOS. Okay, that's the end of this example. Maybe let's try another on the same video. Hopefully it's not a lengthy video now. I'm mixing all my papers. I keep flipping back and forth, trying to keep them nice and clean. And I don't know what happened to the rest of them. Oh, let me find them. There we go. Good. Keep them here. Stay here. Let's try another one. Let's try maybe a bigger problem. So what should we do here? There we go. I don't have anything in mind, just thinking loud there. Oh, there's an example. I'm trying just to find an example here to do. I want a big example. I don't want a baby one. So I found one. Here's this one. Given this NMOS circuit, the following NMOS circuit find I sub D and VDS. Okay, let's do this. Let's say we have an 8 volt here. We'll use 2.2K. This is R sub S, which equal to 1K. This is R sub D. Let's use 100K here. And let's use 100K here. And this is my ground. And my VDS is right here, because that's the drain and that's the source when you have an NMOS circuit. Let me give you a V threshold voltage for this problem is 1 volt. And let's give you K to be, what should we use? Same as the before one, 1/4 milliamp per volt squared. If you don't like the way that circuit is looking, and some of you had a problem with that, you can redraw that circuit. You can actually take it and make it look like this. $1K, $100K, $100K, and a voltage source here of whatever that number, which we call 8 volts. So this becomes your circuit. Again, V threshold is 1 volt because that's positive, because that's a Y. It's an NMOS circuit. K equals 1/4 milli. Just check, putting the papers away. Okay. Now I can actually simplify this because there's no current going in. I can use voltage division, and that voltage here we call VG at the gate. It's 8, it's voltage division, times that resistor, which is 100K, over the sum of these two. And that'll give me 4 volts. So that circuit is getting easier and easier by the minute. This is 2.2K. This is 1K. And I can make that 4 volts. That's all you have to draw. So this is equivalent to this, which is equivalent to what we started with. Okay, once we get to this point, now we need to go through it and figure what we have out there. Now I'm noticing that VG is positive. So I'm going to guess here, and it's bigger than the threshold voltage. So I know that transistor is actually on. But is it in saturation, or is it in ohmic mode? So I'm going to assume here again that the NMOS is in saturation. And let me find my sheet, my handy dandy sheet that has all these things on it. Somewhere, here we go. If it's in saturation, I need to prove that VGS is bigger than the threshold, which we know that that's already passed that test. It's 4 volts versus 1, I think. I need also to prove that VDS is bigger than VGS minus the threshold voltage. I need to satisfy both of these. And if I assume I am in saturation, that means my current I sub ds is going to be K times VGS minus the threshold voltage squared. Okay. And if I fail that, then I'll try the ohmic region, see if that's the case. So let's plug in the numbers. I sub ds here equals K, and what was my K here? 1/4, 0.25, times, if I well, let me put this one. It's VGS, and I don't know what VGS is. Well, I need to know what VGS. Let's look right here. This is G and this is S. I know VG is 4. I know VS is the voltage right here. Well, since this is ground, it's whatever that drop here, so it's I sub D times 1K. So VGS is equal to VG minus VS. My VG is 4, my VS is 1 I sub D, and that's in milli. K and this is milli, they cancel each other out, you know. So if I go and replace VGS in this equation with 4 minus I sub D minus the threshold voltage, which is given to us to be 1, and you square that. Now play with the math. I'm going to just call this I sub D, because otherwise too many subscript. It's 1/4. 4 minus 1 is 3 minus I sub D. It's the same current. It's the same current going from D to S, going through this, going through this, going through that, because there's zero current coming from here. Multiply by 4. And if you FOIL this one, that's what? 9 minus 3 times 2, 6 I sub D using the FOIL method, plus I sub D squared equals 4 I sub D. Move the 4 I sub D there, it becomes 0 equals I sub D squared minus 6 and 4, that's 10 I sub D plus the 9. And now I can solve that for I sub D. 2 equations by 2 unknowns. My I sub D is going to equal to minus B, which is 10 plus or minus the square root of B squared, negative 10 squared, that's 100, minus 4 times 1 times 9, quadratic formula there. 4 times 9 is 36, divided by 2A, 2 times 1. I think that's a 64, which is an 8. Ooh, perfect. So one solution is going to be 10 plus 8 divided by 2. What's 10 plus 8? 18 over 2, which is 9 milliamp. And the other one's going to be 10 minus 8, which is 2 divided by 2, which is 1 milliamp. One of them is going to make sense, one is not. So let's see which one makes sense and which one doesn't. We have to look in what's given to us. Now, if we go back to this equation, where we started here, VGS in it, if I just put back VGS in it, I can solve for VGS. So let me take the first number. I'm going to use I sub D is equal to 9 milliamp. If you plug it here into that equation, directly into this, 9 milliamp is going to equal to 1/4 times VGS minus the threshold, which is what? 1 squared. Multiply by 4, that's milli here again, the millis will cancel. 4 times 9, 36, equals VGS minus 1 squared. Take the square root. VGS minus 1 and plus or minus 6. VGS add 1 to this side, either 7 or negative 5. And it's difficult because now you got to figure out what's happening there. So I don't like doing it this way. I'm not a fan, because now you got to go back and redo that for the other value and see which one is the correct value. Well, that gives you 10,000 things. That's what a lot of people will do. Me personally, I don't like this way of doing it. So I'm going to put an X through it. Nothing wrong with it mathematically, but that's too much work. So how do I do that? I look at my circuit right there. Can you see the circuit? Do KCL right there. KVL, Kirchhoff voltage law. This is 4. This is VGS. VGS, just looking at it, it's actually VG minus VS. And VG is 4 volts, and VS is what? VS is 1K times I sub D. Notice how much easier this one is than that one. Nothing wrong with this. This is like using a GPS. It takes you off the highway, drives 60 miles, puts you back on the highway, zigzag. This one, straight on the highway. You go straight with it. Now, if I use I sub D equals 9 milliamp, what's my VGS? 4 minus 9, which is what? Negative 5. Now, can it be negative 5? We need to prove that what? Where's my condition? VGS is bigger than V threshold. My threshold voltage is VGS bigger than the threshold voltage? Is negative 5 bigger than, where's the threshold? 1? No. So this is not going to work. Well, now let's look at I sub D then equals 3 milliamp. VGS equals what? 4 minus 1K times 1 milliamp, and that's what? 3 volts. Is VGS bigger than V threshold? Is 3 bigger than 1? Yes. So that is the right current, at least for now. Well, I proved one condition, that VGS is bigger than V threshold. Can I prove this condition, that VDS is bigger than VGS minus V threshold? So I need to know what VDS is. Going back to my simplified circuit, where'd you go simplified? I have it somewhere. Oh, is it behind under this? Oh, right here. This is 8 here. Let's find out, this is DS here. The 8 volts on the top should equal the 2.2K times I sub D plus VDS plus the 1K times I sub D. 8 equals 3.2K I sub D plus VDS. Well, I sub D is 1 milliamp. 8 equals 3.2 K times 1 milliamp. The 1 milliamp came from here. Oh, 3. Is it 3 or 1? That's a 1 milliamp, not a 3. 1 milliamp I sub D, not a 3. I wrote 3, but we did 1, so it's the correct math. I just wrote 3 here, which is 1 actually. Too early in the morning, 6 a.m. in case you're wondering. Plus VDS. So VDS is going to equal to what? 8 minus 3.2, and that's, what's that, 4.8 I think? So VDS equals 4.8 volts. Let's see if I'm good. I still need to validate this condition. Is VDS bigger than VGS minus V threshold? I satisfied that. I already did that. So I need to check this one. So is VDS greater than VGS minus V threshold? That's 4.8. Is that bigger than VGS? What was my VGS? My VGS was down here is 3 volts minus the threshold voltage, which is 1, is 4.8 bigger than 2. Yes, it is, and my assumption is correct. So my assumption is correct. So my numbers are good. This is my VDS, that's my VGS, and this is my I sub D.